Bismillahirrahmanirrahim. Greetings. Most of the textbooks, if not all, they write x square root of x squared equal to absolute value of x, as I have written. Then they write in front of it by definition. But they do not indicate or mention what was the motive of this definition, of coming up with this definition. Now, in this lecture, I'm going to discuss about the motive behind this definition and also the benefits of this definition. And I have already uploaded 2 video lectures as a kind of preparation and background for the concept of this video. So if you haven't watched them yet, I strongly encourage you to watch them so that you will have sufficient background to fully comprehend the contents of this lecture. Alright, then let's get started, shall we? Now, this, I guess I take it out and put it here. Sorry for my primitive equipment, but as long as I can convey the knowledge and the message with this primitive equipment, you should be happy. I am happy. Now, here, you are familiar in the previous video lecture, I have explained what that means. Now, these 2 notations are equivalent. As the meaning of the equivalent is concerned, means even though they look different, but they are conveying the same word, the same message in a sense. So if they are equivalent, they are also interchangeable. Alright, now let's see what I mean by do in kind of application of this interchanging these 2 notations in a sense. Now, we all agree that 2 squared is equal to negative 2 squared, huh? It's a grade school question. 2 squared is same as negative 2 squared. So we expect that a square root of both sides should be equal. If 2 numbers are equal, we expect that a square root of them to be equal. So we take a square root of both sides. Then we go ahead and interchange to the previous one. You remember I said this and that, they can be interchangeable. You know that this one. So we go, excuse me. So this one, so we go ahead and exactly according to this agreement, which is a to the m to the n, we interchange this one to this notation, all right? And then we come up with 1/2 times 2, a to the m to the n is a to the m times n, 2 times 1/2 is 1, so we get 2. Now, look what happens here, what we do. When we write negative 2 to the 2 to the 1/2, 1/2 times 2 is 1, and negative 2 to the 1 is negative 2, is not 2. You follow me? So that means that even though the 2 numbers were equal, looks like their square root did not end up to be equal. So what's going on? Why is there any kind of ambiguity or contradiction? Now, mathematics is very kind of concise and meticulous and precise subject. So if there is any kind of ambiguity or any kind of contradiction, immediately the mathematician make a definition to filter away that contradiction or that possible ambiguity. So that's exactly what we are going to do, to see what kind of agreement we can come up so that we don't end up with this ambiguity. Okay. Now, if a number is non-negative, I don't have to say non-negative. We know that 0 is kind of trivial cases most of the time. So you say f is a positive number, let's say, then a square root of a is what? This notation. What is he saying? He said is a number. This is a number that if we square it, we get a. That's exactly what this notation means. So a square root of a, where a is a positive number. If a is negative, is a different word, is a complex. That's way outside the context of this this lecture. So if a is a non-negative number, this notation is asking the question, what is the number that if you square it, you get a? Now don't let that to turn you off. Learn it through numerical example, because that stay with you much longer. So, I mean, the more kind of explicit to comprehend it. Now, a square root of 4 is a number. This notation is a number, such that if you square it, you get 4. So if somebody asks what is a square root of 4, then you say it's a number that if you square it, you get 4. Then to answer this question, what is the number that if you square it, you get 4, the answer is plus 2 or minus 2. Because both of them, if you square it, you get 4. All right. Now these two numbers that I just mentioned, 2 and minus 2, they are called roots of 4. So every positive, I don't have to say non-negative, every positive number has 2 roots. One is positive, one is negative. And both of them are on the number line geometrically, they are kind of mirror image of each other with respect to the origin to be the mirror. Now, we come back to a square root of 4 again. We are learning this through example so that we can comprehend it rather than using letters of alphabet which stand for generalization. Now, a square root of 2, suppose we want to solve it, all right? We want to solve a square root of 2 less than 4, or another problem, a square root of 2 equal to 4, or a square root of 2, a square root of x is greater than 4. So suppose these 3, one of the 3 we are interested to solve, maybe a problem like that was given. So what do? We take a square root of both sides, and please do not become a mechanical. Always try to concentrate, think, reflect, and what you want to expect before you start doing work. Now, we take a square root of both sides. Is that right? Now, a square root of x squared equal to x. If the square root of x squared equal to x, then a square root of 4 is what we already mentioned, is plus or minus 2. So then x is equal to 2 or is equal to negative 2. So we have now 2 possibility. If we are solving inequality, then x is less than 2 or x is less than negative 2. Again, it's kind of possibility and ambiguity. Then if you are dealing with problem solving with greater, then is x, the unknown number, the letter that stands for number, is it bigger than 2 or is it both, or is it bigger than negative 2? So you can see that if we write a square root of 4, 2 or minus 2, we will have what? We will have 2 possibilities, and we cannot flip a coin and select one. So we have to come with something so that we overcome this ambiguity, and that is exactly where the concept of principal square root come from. So principal square root will filter away this kind of ambiguity. Let's see how it does it. Now I have said that one, I kind of repeat one more time because it's very important also for some of you who may want to write notes. And that is that every positive number, non-negative or positive number, has two roots, I already mentioned. Then one is positive and one is negative. So in case of this, 2 and negative 2 are two roots of the 4. Two roots, they are called roots, the name of them. Then let's say 5 and minus 5 are two roots of what? Of 25. A square root of 3 and minus a square root of 3 are two roots of 3, because 3 is not a perfect square. Do you follow me? Okay, so we are familiar what root of a number means, root of a positive number means. So every positive number, we show that has two roots. Is that right? Now, here comes the concept of principal square root, and see how this principal square root is going to filter away the ambiguity that we had. So by principal square root of a number A, we always mean the positive root of that, because every positive number has two roots. I already mentioned, I keep repeating that. By principal square root, we always mean the positive root. That's all. That's what principal square root is indicating. Now, by the definition or agreement of principal square root, a square root of 4 is no longer equals to plus or minus 2. A square root of 4 is equal to 2, the positive root of that. I have written for you, Since what? Since 4 has two roots in reality. So when we write a square root of 4, we mean 2. Then this brings about a good question, a curious question. You, me, mentioned that just a minute ago that every positive number has two roots. So what happens if you are in need of the negative root of that number? As a matter of fact, there are many problems in mathematics that we do need the negative roots. And there are problems in mathematics that we need both of the roots of the positive number. Then principal square root is going to be interfering. The answer is no. The principal square root does answer that question as well, very beautifully. Let's see how it does answer that question. So what happens if you are in need of the negative roots? What is principal square root is going to do for us so that we get the negative root of that? Now, look at this carefully for this notation. Is answering that question as I just asked. When we write a square root of 4, we always mean plus a square root of 4. But we don't write the plus in front of it. So if you don't see plus in front of it, that means, like this one, that means plus. That means positive root. If you write it, in fact, if I'm teaching for my beginner student, I do encourage them to write that plus, so that you know you are talking about positive root of that. But because most of the text they don't, so we get used to it that if there is no sign before a square root of 4, that means positive root. Now look what happens. By a square root of x, we mean always, I have written that one. Of course, if x is what? Is a positive number. We always mean positive root, positive. Now, what happens if we want a negative root of that? The answer is easy. Just put negative in front of that. So if I write negative square root of 4, I mean the negative root. That's simple. All right? Now, a square root of 4 is 2. Is that right? So put negative in front of that. Let me cover it. Put negative in front of that. I have something here I could do. Put negative in front of it. That means what? That means we want the negative root of that. And it's same as in multiply both sides by negative in a sense. So it's negative square root of 4 equals negative 2. So again, the principal square root is answering that good curious question. So we have no problem whatsoever to see which root of the positive number we are going to deal with, or which root of a positive number we are in need of. Do you follow me? And if we want both of them, we write plus or minus. If we need both of them, we write plus or minus. As a matter of fact, in quadratic formula, you will see lots of places that they write plus or minus a square root of b squared minus 4ac. You have seen that. Okay, now comes the moment of truth. Now comes the moment of truth. Let's see what that is. What we started this lecture with. And that is, we are dealing with x. Is that right? What is x? In the first two lectures, I gave very good, deep, discussion about that. X is an unknown representing a number, which means what can assume different values that we assign for that. So x is an unknown number. We don't know, can be positive, can be negative, can be zero. There are only three possibilities. Now, x squared is definitely a positive number. So we have no problem with writing a square root of that. Because what? Because the radicand that we are dealing is what? Is a positive number, and every positive number, I repeat myself, has two roots. All right. Now, if a square root of x squared equal to x, that most of the students, they do assume, and the textbook doesn't say why, the absolute value. If a square root of x squared is x, but x can be negative. X can have a negative value. X can assume negative number. So if you write x as x square root of x squared equal to x, then you are in violation of definition or agreement of principal square root. You see that? Example is like negative 2 to the 2. Negative 2 to the 2 is 4. So we have no problem. Inside we are dealing with a square root of 4. We are not dealing with negative number. So that we say is a complex, we cannot deal with that. So we are dealing with a positive number, but the outcome, if we change, as I already done it, if we change the equivalent form of that in the form of a to the m to the n, we end up with negative 2. But principal square root says no. The square root of positive number always we mean positive root. And here I didn't write plus because I already mentioned if there is no plus here, we always mean positive root. So what do we do if it is x? X is coming out of it. It's not number coming that we know is positive or negative. We know cannot be negative, so we write the positive. It's a number. We can see it as a constant. What do we do if you are dealing with x? The answer is easy. Put him in the jail of absolute value. Put it in the jail of absolute value. So now you have no fear what x value will be. Now x can be positive, can be zero, can be negative, but the outcome of absolute value of x, that's what you are interested in, is always non-negative. Fantastic. Isn't that? That's beauty of mathematics. You see how nicely a mathematician filtered away the troublemaker in a sense, filtered away the ambiguity, filtered away the possible contradiction, and he came up with very nice small definition. Of course, I'm not going to go through the rigorous mathematical definition of principal square root. I made examples to follow it very nicely. When you go upper courses, then of course they are not going to use numbers for you if you are in graduate school or something and you are also advanced enough to deal always with variable and with abstract kind of condensed definitions. All right, now let me see if I have any other one. Yes, I do, in fact. Whatever I just said, I have put it in writing. So for those of you who like to turn notes. But my advice, as I have mentioned before, is that think, reflect, concentrate, and try to improve your critical and analytical thinking. Unfortunately, this is a video lecture, so you have the upper hand on your computer to stop it, pause, and think, and put them in your mind rather than keep writing notes. All right, you have. It's a fascinating technology we have nowadays that unfortunately we didn't have in the past, in my time. Okay, now what I said here, I have written, maybe I could repeat one more time, is that if a square root of x squared equal to x, then what happens? Then a square root of 4 equals negative 2 squared. When we, a to the m to the n, when we change the notation, we end up with negative 2. But principal square root told us that if you write it like that, there is a plus, but if you don't write it, means plus is there, so the square root of 4 by principal square root cannot be negative. So what do? We just put it in absolute value. When we are dealing with number, we know we can write a square root of 4 equals to 2, finish. We don't write it equal negative 2. Is that right? But when we are dealing with variable, when we are dealing with the unknown, when we are dealing with the x, x can assume negative, positive, 0 values. So in order to overcome that, we put it in the jail of absolute value. Okay, then now let's look at the one application, in a sense, a simple application that to see the benefit of that, the benefit of this definition. This definition has a lot of benefit. It's a fantastic. That is the good part that mathematician come, and it's not just to say absolute value of a square root of x squared is the absolute value of x. Now look what happens. Suppose we are asked to sketch the graph of x squared less than or equal to 4. Most of us, a basic algebra question. So what do? We take a square root of both sides. Is that right? First two, not mechanical. We know we do that. Now, when we take a square root of, a square root of both sides, we now know that a square root of x squared is absolute value of x. So we write absolute value of x, a square root of 4 is 2. Now we cannot write negative 2, because absolute value cannot be negative. So we have, it eliminates to make a mistake and write it negative 2, number one. And number two, look how fantastic the graph of that comes so quickly, we can say that. We went over that in the first two lectures, the geometrical interpretation and geometrical drawing of an absolute value. So absolute value of x less than or equal to 2 end up to be what? This interval from 2 to negative 2, all the numbers including 2 and negative 2, because it's less than 2. Less than or equal to 2. So that is the graph of that with respect to what? With respect to absolute value interpretation and geometrical interpretation and putting them on the number line. So how fantastic we came up with a solution rather than going in a sense, I don't know what to say if you write a square root of x squared equal to x. Now, we don't even need inspection in a sense. It's so fantastic, quickly we came to the answer. Now, this is also the set raster notation of that, which is same as this one. So we have a geometrical representation and the set raster notation. Okay, then, this was the third and the lecture about this, this subject of principal square root and the concept of absolute value. And I hope that was beneficial to you. And I encourage you to always train yourself to think and reflect and improve your critical and analytical thinking and don't become a mechanical and recipe following. Okay, then I thank you for watching, and I wish you all prosperity and good health, and please stay safe. So long.